Welcome, everyone, to today's Talk Polymath episode. I'm Terry Schindler from Polyplexus. For those of you joining us for the first time, Polyplexus is the host of this podcast. We're a platform for scientific and technical creators focused on accelerating interdisciplinary connections and innovation through evidence-based conversation. You can join us at polyplexus.com. So now let me introduce our Talk Polymath guest. We're so pleased to have Dr. Eric Klingenberg from the Mars Advanced Research Institute, where he leads the materials science platform. Welcome, Eric. We're happy to have you.
Hi, Terry. Thanks for having me today. Glad to be here.
And I think that everyone listening is probably familiar with M&Ms, Twix, Lifesavers, but maybe less familiar with the Mars Advanced Research Group. So maybe you could start by telling us when the group was established and why.
Sure. Yeah. So the Mars Advanced Research Group was established in 2013. And really, it was established a bit out of the recognition that, our brands and our brand teams, right? So we have three major divisions: Mars Wrigley Confections, which you're most familiar with, Mars Pet Care, and Mars Food, and Edge is the third one. And so what happens is those segments get very focused on research today, driving the business, what's happening right now to drive stuff. And there was a recognition at the sort of corporate level that we might be missing stuff on the horizons, right, that we could bring in faster if we were involved in. And so that's really the genesis of the Mars Advanced Research Institute. We're a small group, a bit modeled after DARPA, right? There's a few of us scientists, each with a different discipline. And our role is to really look at the outside, work with external research partners to identify technologies that would spark innovation, right? And then bring that more rapidly into Mars through funding and partnership.
And so I know you also have, and we don't need to belabor it, a brand initiative around sustainable in a generation. How does your work contribute to that effort?
Yes, our group contributes across our sustainable in a generation plan. My role as a material scientist is really, the last 3 years has been focused on packaging and really looking at how we can improve our packaging to be more recyclable, to use less packaging, to decrease the amount of packaging we're using, and really to do that quickly, and what new technologies are out there to do that. So I'm specifically focused on packaging. There are others in our group that might be more on regenerative agriculture, or others that are talking back in our supply chain. So there's some interconnectivity, but we fit across as a group, and our projects sort of match up to those sustainable generation plans.
So interesting. So let's talk about the scope and challenge of public packaging in snacks. So how big is it? Now, let me start by, I'm asking you that question, but I'm going to ask a more specific question. Frankly, today, does plastic recycling work? Because I've read that only 2% of plastic packaging is recycling in same or similar quality products.
Yeah, so I think you're adding a lot of clarifiers on there too, which is what we get at, right? And I think this is the confusion across plastics and the recycling industry. And I think it can work, and I'll clarify it. As we go through in different regions of the world or different parts of the world, it works at different levels. And that's including different materials. And so part of our challenge is that, recycling is different even town to town. I think if you live in the United States, right, one town accepts certain materials for recycling, the next town is different. So it gets to a high level of confusion. I think there's more to it there that goes back and forth, and for snacks and packaging, I think you have to really step back and think about why we've done what we've done in packaging. And so, I like to think about it from a snacks or food packaging and on-the-go packaging perspective. Is we focused on front-end sustainability. So moving to flexible packaging, we've become extremely material efficient. We use less raw materials, we can pack more in trucks, we use less gas and fuel to go around to distribute our products. And so there's less waste ultimately. but that becomes really hard to recycle them because recycling is based on mass. And so we often do complex structures to get the performance properties we need in these flexible packaging materials. And then that renders them almost non-recyclable by current methods.
Oh, how interesting. So let's clarify for everyone. What does flexible packaging mean?
Yeah, so flexible packaging, think of, for Mars, a Snickers wrapper, a chips bag, a bread bag, all those thin films of packaging that go out there. And, the majority of Mars portfolio, I would say, is flexible packaging. We have some
Got it.
rigids that are more, have more structural integrity. But I think you've seen a lot of people move away from the rigid plastic to flexible
Got it.
plastic just to take out plastic. So
Right. And also that was why I was trying to understand the scope of it, because when I think of a package of M&Ms or a package of gum, I don't actually think of that the same way I think of, let's say, plastic soda bottles.
right.
And so what, but the scope is huge, right? Or you wouldn't, that's why you're looking at it.
Yeah, no, absolutely. And I think that's, probably a great example. So when you see a soda bottle or a water bottle, I think most consumers say, oh, recyclable, I know what to do with that, right? Because it's a format, it's a, limited in terms of design, right? Not a lot of different plastics in there.
Right.
And then when we get to something like an M&M's wrapper or a chips bag, there's multiple layers of different materials in there to make that function, but we've reduced the amount of plastic or packaging that we have to use and we have to ship. And so, yeah, it's a challenging problem because we were focused so much on the front end, I think, as an industry and all the good that flexible packaging does in that front end, that we've kind of missed a bit of the back end and how hard it is to recycle those, and they just don't go away. I think on the other side, what we worry about is people are so focused on recycling today that they forget the front end sustainability metrics that we've already achieved. And so how do we balance those for a better future? And that's really a lot of what we talk about is, don't think of flexible packaging as ultimately bad. Think of it as good, but how do we help better design for the end of life as well? And so can we find the sweet spot there?
And so let's talk about, like, what would you compare the opportunities you have here to look at the end of life for flexible packaging? How do you think about it? How do you break that down?
Yeah, so I think we break it down like most companies break down. One is, can we reduce the amount of packaging we're using, and certainly virgin plastic? And so that comes, for you as the consumer, you would see it as less excess packaging, right? So we don't double wrap things as much. We're more conscious of that. Maybe smaller bags, right? So when you buy like a chips bag or something, there's air and space built in to protect those. Can we take away some of that head space? The other portion of that is, can we reuse? And so a lot of things, depending on the business model we're trying to approach, is, can we do reuse models where we design a package that's more durable, but we can have a reuse for that packaging? And so, much like probably when I was young, I remember taking the soda bottles back to the grocery store and having them reuse them. Can we do that and make it work economically and sustainably? And then we focus on, after those two, we really focus on recycling and compostability. And so there's probably room for both. It depends on region and application that we're doing, but can we redesign to be more recyclable? And, in other cases where we see things that are challenging to recycle because it's associated with food, it's got a high food contamination, it's really small and lightweight, can we design it to be compostable and fit a recycling stream there? And so I think those latter two become extremely challenging because it's not just a materials or packaging design problem, it's an infrastructure problem. It's a consumer problem, right? It's just way more complicated than, here's your new package design, here you go, and somebody's going to solve it.
Yeah. So I have two questions based on that. Hold the consumer thought, but is there one opportunity here? Is there anything that looks like low-hanging fruit from a research point of view, or is all of it just super complex?
It's all super complex, and that's part of the excitement around it. We see advanced recycling, and so these chemical recycling technologies that would enable us hopefully to get back to a virgin like plastic. So you talked about equal use in the beginning, right? Does recycling work? Is it equal use? So not just taking, say, the plastic and making a park bench or a bucket out of it.
Downcycling,
right?
Yeah.
So I think those are great opportunities, but we don't get back to the original value, right? And performance properties. And so how can we do that better? So there's some progress in advanced recycling and in different places, and we support those activities, and we're curious as to how they'll play out. I think it can be difficult because we've got to collect a lot of material. You've got to still sort and clean and do stuff. And then, on composting, there are different challenges. One is we have a whole new material set that we have to play with. We have to think about what really happens, because we've designed packaging for traditional plastics, based off of polyethylene, polypropylene, mostly in the packaging industry, and PET for bottles, so the polyethylene terephthalates. But when we talk about plastic packaging, it's complex. There are certain properties, and when we say, okay, now we want it to be compostable, well, how do we maintain those performance properties, but then design in compostability
to degrade
level, right? Yeah,
yeah,
exactly. Yeah, so it's a challenge.
So, and I want to get into some of what that challenge looks like, but before I do, it does strike me as an interesting situation in research, because it seems like there's both a consumer education and behavior problem as well as a research problem, and those don't always go hand in hand. Because nobody really understands. Like, I mean, I used to have a sign at the recycling center near me that said, "A quality sort depends on you." And I just felt so much pressure. I was like, I'm not sure what I'm doing. So, and yet you've got your research problems as well. And so do you think about the consumer education behavior issue, or are you just focused on the research and science?
We think about it all the time, right? I think there are some they'll say we just have to educate the consumer more, right? We have to educate the consumer more. And I think educating the consumer is a good thing, and I think it helps. But in reality, we need to make it simple as well.
Mm-hmm.
I gave you the bottle example. Do you know what plastic your bottle's made of?
I couldn't, without looking at the bottom of my bottle, I would not be able to tell you that.
And it's a number, right? So it's a number that's confusing to people, but your bottles are made out of different plastics, whether it's a water bottle or soda bottle, and those get segregated at the recycling, the collection and sorting center before they go off to be recycled. So what I would argue is that while we have a lot of on-pack labeling to help educate the consumers, one of our struggles is if I make a package for a product from Mars, and a competitor does a similar package and it looks the same, but it's made out of different materials, it may get sorted differently.
Right.
And that's a real challenge in the industry now, is how do we get through that with the consumer, but also, are there things that we can do, higher level beyond us through government regulation, EPR, to focus on making sure the right applications use materials that are recyclable and easy to sort at the sorting centers, but also recognizable by the consumers to sort.
Okay, so that's a great segue, because you said, I know I've read some things you've said about innovation is like a team sport. And so now more than ever, the opportunity to change things has to go beyond competitive boundaries. But at the same time, you're all individual companies. You're a very large company. I think you make more revenue than Coca-Cola. What do you see as the most promising possibilities for innovation across competitive boundaries? Is it more a set of standards? Is it,
Yeah, I mean, I think that helps, but I think also, as we go out and talk, as we've learned in this space, you're seeing our messages are surprisingly similar. right, for the sustainability and then recycling. I think the other thing you'll see is that there are many of us that join similar consortiums. So the
Right.
closed loop consortium on composting and others, we have active roles in there with competitive and peer companies where we're providing guidance and opinion from our company's perspective, but the closed loop is really signed with rolling that up and what does that mean and how do we innovate and what's the state of the industry. And so I think those are good things to have happen. You mentioned, as we're preparing for this podcast, the DOE workshop that I led with the Advanced Manufacturing Office and Bioenergy Technologies Office, the DOE. And really that was part of us saying, oh, we need to really talk through this as a group and get together and hammer out where are the challenges and really be specific about what challenges we're facing so we can have governments know where to put their funding. Right. So it's like, we're kind of defining here's the challenge space. So governments can say, okay, we're going to fund this aspect of the research because we think the collective thinks that's the challenge, right? Or these are the 4 areas. And that all helps us together. Right. And I think that's where we're very pre-competitive in that stage, why we're sort of directing and identifying the challenges where we want researchers to focus.
So that's really interesting. So let's talk about some of those collaborative innovations that are sort of coming about. So I've heard about biomimicry inspired packaging design. What does that entail?
Yeah, so I think when we look back at a lot of things, nature is just this wonderful, amazing area that, nature does things that we can only think about sometimes. And a lot of what we're trying to do is, when we go back and say for barrier properties or something for packaging, we look at back, how does nature design a barrier for packaging, right? You've got oranges, bananas, apples that have a sort of natural packaging on them that last, right? And make those fruits last. How do they work? How are they structured? Can we think about that? Can we take those, learn from those design elements and mimic them, right, in a package to get what we want? And so it's not just, put metal foil down, wrap it in metal foil and seal it up and it's good to go. It's, what does the package really need to do for our product shelf life? And then can we design that in and can we do it efficiently and economically and still enable recycling? So it's a biomimicry in a sense. We're taking learnings from nature and turning it into using it for sort of our applications.
And I think I mentioned to you at the beginning, I feel like every day you open your phone, there's some news article about a breathless headline about a new microbe that eats plastic and we're going to be fine. And they're going to just eat all the plastic and that'll be fine. But maybe you could talk a little bit about biological recycling and what that does really look like and how feasible that is.
Sure. Yeah. And I'll just lead off with, I think we live in interesting times, right? So I know what Polyplexus is trying to do, and I think bringing together scientists, and I think it's awesome. I think we also live in a time where it's easy to get sound bites out, and it makes it more challenging for us as researchers and others because one of the things we have to do is we have to sort through all that to say what's real, what's not real, and we're getting inundated with it every day. And so, I hear things like we got a new microbe, we got a new enzyme. What I'd say is 90 some +% of the time that's focused on polyethylene terephthalate, and those are technologies that people are developing, but it's one plastic. And I think we tend to think of things more on application. What are the properties? What are the performance? And it may not be one plastic that solves the problem. So I'm a firm believer that there's no hero material out there that's just one material going to solve all our problems. We're going to have to make these complex constructs. And I think, that's true whether we're doing recycling. So people are doing that with polyethylene and in different ways you stretch polyethylene or produce polyethylene. It can be more chemically recyclable through pyrolysis or through those advanced recycling technologies. In the biological recycling area, really what we're looking at is, either aerobic or anaerobic recycling. So using microbes to break down materials to use products, right? So CO2, water, and biomass that can be used as a soil amendment, fertilizer on the back end. And so that can be either through, anaerobic digestion systems, and most often you're going to hear us talk about composting systems. So really where we're using, aerobic systems, food waste, yard waste, how do we compost at scale and do that in an efficient manner? But it all depends on microbes breaking it down.
Okay.
Really biology getting involved.
And, we've talked about the difficulty with all the different regulations, even town to town, right? Municipality to municipality.
Yeah.
If there were at some point a breakthrough, let's just say in chemical or biological recycling, that really was impactful at scale, do you think that change could come bottom up so that you would say, hey, government, this works at scale? Now, like, do you think you have to have the solution before you can get the standardization across all these things, is I guess my question.
Yeah, I think it's mixed, right? So I think we're seeing take composting, for example. We're seeing a lot of local composting, be very successful, right? And diverting food waste and a super important thing to keep food waste out of landfills and turn it into, valuable product instead of just landfill gas. So they're running successful businesses, they're doing good things, and I think that's what we're seeing with the U.S. The bill that's coming through the United States on waste infrastructure. Composting has made that. It's starting to get to the government level where the government can, hopefully it passes the House and the government says, yeah, we're going to fund more composting around so that it's not just grassroots. So I think that's a great example of where maybe some local things have started that have now sparked to a higher level. I think the other side of it is the higher level pushdown still has a role to play, help us clean up, setting some guidelines, making sure that it's, there are consistent standards for evaluating things, and the compostable area is one of these that's new, and we're working on this with the US Plastics Pack, the Closed Loop Consortium, which is, how do we define the rules, the design principles for packaging that's intended for composting? We have composters that we're talking to and are on that same work team that are giving us feedback as to what they would want, what they don't want. So really working across the systemic value chain, if you will,
right,
to start to define what it is we want and what it is we need. And so I think, on the call this morning, even with the team, there are people that have compostable phone cases, and we're kind of like, great, don't want them, right? and I think that's partly because, it's not associated with food, so it's not helping us divert food, and it's not a contaminant in the compost system today because it's not food packaging. But man, if it's compostable, it will be a contaminant, and then we're just challenging the system more and more. So again, what should be compostable, what shouldn't,
so
I think is
interesting. Great. Yeah. And I'm trying to digest that, no pun intended. I think you've also been outspoken about the need for a new type of thinking in which waste and recycling are seen as a resource and provide an opportunity for high value products. What do you mean by that?
Yeah, I think this is a great example, and composting is one of them. So I, love it. I think it's a great opportunity for the future, and especially in communities that may not have a lot of waste infrastructure, composting can be easy to set up, and one of those things we can do. But when we talk about recycling in general, and you've talked about it, we downcycle often, or you hear those comments, right? The value of the products is in the performance that we have, right? And so people think, well, the value is in the material, but that material is essentially zero value now that it's outlived its useful life. We go into the recycling system, and then we have to create value from that material on the outset, and it's usually by mass, right? So what is the mass of material, and what is the volume of material? And so for aluminum cans, that's well defined, and you see the recycling go up, for that particular material. As we go forward into composting, there's so much more there that we can do with biology than just generate soil or generate methane and CO2. And I think we're seeing that in the forefront of, what we see in the sciences, right? So you see new enzymes making meat. You
Mm-hmm.
see other waste programs. There's companies that actually make some of the polymers that we'd like to use that are compostable polymers and plastics from high organic waste content. And so when we rethink that, there's a lot of innovation that could happen at that level to say, we're not just going to generate soil. That's, amendments. That could be one of our products, but what else could we do to drive the economics of the system, increase collection, and help them generate money? And we're just sort of at that time frame in the science world where DNA sequencing is cheap. We're able to start really defining enzymes and new biological pathways. So what else could we do in that space to really open it up?
So really reframing the problem.
Yeah, really thinking about it not from just our packaging side, but if we want to take care of waste in general, and we can sort, how do we make economic value instead of just digging a hole in the ground, right?
Mm-hmm.
And I think that's what drives it is, the economics are going to drive us collecting waste and turning it into something new. So we have to be thinking about how do we develop valuable products.
Yeah,
So,
it's an economic problem. It's a science problem. It's a consumer problem.
right.
There's a lot of intersecting. It's a government problem, right? There's a lot of intersecting.
Yeah. If you're an ambitious problem solver that likes to connect with other people, this is the place to be. I mean, seriously, it's the number of people I get to talk to outside of the science field or within the science field, and I would say there's a lot of passion about this, which is great, and a lot of people want to do the right thing. So there's this, sort of openness to banter things back and forth and be okay to be wrong, or but you're willing to listen to the other side and hear composters' problems, or put your boots on and go see a compost facility and see how they really operate. It has been fantastic for me. It's a great learning experience, and it's really, changed my thinking around how do I develop new materials. Right. So you sort of walk that value chain a bit, and that perspective it's just, you can't put a value on how important that is.
So you mentioned earlier the Plastics for a Circular Economy initiative with the government, so with DOE. Can you explain a little bit further about that initiative and maybe how we or how Mars thinks about a circular economy with regards to plastic?
Yeah, so really we hope that our plastic packaging never becomes waste just in a landfill. We hope it gets turned into something more useful. And so that's really what we mean by that circular economy, is keeping our plastic not as just a waste that fills a hole or is somehow littered. When we're looking at that as, how do we design materials or select materials on the front end, but also that back end? And that's really what that workshop was about, is not to say there's one right or wrong recycling methodology. There's not one right or wrong material. We sort of broke it down by different pathways for applications, different recycling, and what are the challenges for each. And then, we even think about what applications fit that. And that's really about having that discussion among scientists, material providers, waste handlers. So, waste management was there giving talks, composting facilities were there giving talks and providing feedback. And so bringing together those people to really talk about the challenges and define potential solutions, but then highlight where we needed help, right? We don't know. And I think, that's the important part of science, right? What don't we know? You kind of start to talk about, okay, we don't know this area well enough, so let's go research it. Or we don't have a material that could do this. Let's go figure out if we can make it happen.
And throughout, is there a sense of urgency around the problem? Because I think, I don't know, maybe MacArthur Foundation predicted by 2050, the oceans will contain more plastics than fish by weight, assuming current rates of leakage and growth and consumption. Is there a sense that the clock is ticking as you're searching for these innovations?
Yeah, very much so. So there's a sense that the clock is ticking, and we're always like, oh my goodness, we're running behind, right?
Hmm.
But there's also the sense of there will be technology nodes that will hit along the way, right? And so first order of business for someone like Mars is, okay, let's take all the excess plastic out that we don't need.
Yeah.
Let's get it gone, right? It's something easy we can do. Let's make it happen now. Um, the other side of it is, can we, where can we source and get recycled plastic content that's approved and certified for our packaging, and let's help that along, and let's bring it so we start to help the recycle industry. And I think as we go down there, we'll see that progress through, but it's not one answer. And like I said, the timing's different for each one. And so I think
Hmm.
compostables is probably further out. You're hearing a lot more about it now because people are focusing their energy there. But if we look at the amount of resin in the world today for that's truly compostable, it's really small for our packaging needs. And so where we work with the resin providers and the converters, and we start to say, okay, well, let's focus on some of these applications. Let's help you build up. Let's commercialize this one. Let's get your scale up, and let's bring it into the marketplace as we continue to go. And that's sort of hand in hand with us trying to work with the composters and everybody else to,
Yeah.
will you
I was just
accept
going to
it? Will you
say,
certify it?
yeah.
So it's not just us
So incremental
wanting.
changes and more seats at the table. Is that
Yeah.
somewhat of the approach?
Incremental changes where we can. And, groups like ours where, we're partnering with these other companies to really bring things to the forefront and see if we can do it faster.
Yeah.
So that's why Mari exists is more, can we put some money and some brains and resources around some of this stuff and help accelerate it.
And that is a good segue to the question I wanted to ask you. You work with a lot of partners and academic institutions. How do you normally solicit them, and how do you tend to work with them?
Yeah, I think
You mentioned a DARPA model. I'm just curious.
yeah. So one of the things is we have the challenges, and we can put out challenges at times. I think we go through the workshops, and internally we've selected areas that we want to work in. We've identified people around the globe that are working in those areas and doing good work. And then we start to approach them and develop the relationships. I'd say first and foremost that they've got to be doing the good science in the areas that we want, and have really similar goals and, let's say, culture, right?
Mhm.
If you just want to make money off of it, from that standpoint, and you're like, I don't care, we're just going to make money, and then you go down it, probably not a fit for us, right?
Mhm.
We want to identify the science. We want to make sure we're doing the right thing. We're not going to overhype something just because you think you're going to make money off it. We really want to solve the solution and make money off it. I mean, it's important, but you know, we're not going to overhype something just because you think you have that answer.
Let's quickly talk about the disciplines that are really intriguing to you, the interdisciplinary nature of the work that you're doing. So I know waste management, composters, but in the sciences, what are the disciplines that you think may have some insights to bear?
Yeah, certainly chemistry, material science, physics as we go through some of those, the mechanical sciences as we think about machining and what we're doing. More and more the biological and agricultural sciences. It's just
Interesting.
been fascinating to us as we think about how new materials are made, how they're consumed. So we have programs that we're looking at that, when things degrade, how do they degrade? What's that science of that degradation? Are we sure everything's good? We're not
Hmm.
generating chemical intermediates along the way that might be bad, because we're talking about putting things back in the earth and back in the soil. And so we're really heavily leaning on those people to help us understand what's happening in soil conditions and marine conditions, and what those
Interesting.
degradation atmospheres are like,
Hmm.
and how they attack materials. So there's when we go through there, that I think that's super exciting. I think the soil chemist, right, and agricultural people, as they're evaluating microbiomes of soils, is, how does composting help? But if our material's in there that we're designing as a packaging, is it good? Is it bad? Okay, let's screen down on these. And so for me, super excited in that area. And then, probably lastly, some of these engineering aspects of how do you make the full process work, right? Especially from an anaerobic digestion or other area.
So to that end, since we're talking to a research community here, 30 minutes isn't nearly enough time to talk about sort of the intricacies of this problem. Is there anything else that's important to consider that we haven't touched on that you're like, wait, and let me leave you with this thought?
Yeah, wow, it goes fast, doesn't it? And I could talk to you all day about this, as you can probably tell. It's a passion of mine. I think the biggest thing is we have a lot of people focusing on new materials, and we see a lot of new materials come out of there. I think thinking about the design, not just how we get it from economic scale up, but how do we do that package design, for composting or recycling and still maintain performance. And I think the back end, right? I think there's more research needed. How do we turn biological waste into valuable other materials? How do we think about driving those economics of the back end so that we can, sort of do the pull through? Because today it's just, put it in here and we've got soil amendment and valuable, but could we make more value out of that and really drive things through an economic model, not just we want to do good model?
So if someone's hearing this and they have either research on that or knowledge about that, and they wanted to contribute expertise to any of your efforts, what would be the best way for them to do that? Reach out on LinkedIn or?
Reach out on LinkedIn, tag me, get a hold of me, and we'll figure out how to connect and talk. And we'll introduce you to a bunch of people as well. I think that's one of our great jobs, is we get to introduce scientists to other scientists to help make the world a better place.
Well, thank you so much, Eric. Really appreciate it. I could also talk about this for much longer because it's such an interesting, I'd like to have like a different episode on every aspect of this, but thank you for your time. And we're going to put all this information at the bottom of the episode so people will have your link, and also maybe some of the materials from the circular economy that you talked about. We appreciate it.
Thanks so much, Terry. I really appreciate you having me.